Let's think about the last case when rho is minus 1. It's a simple extension. When rho is minus 1, okay, when rho is minus 1, suppose, what if rho is minus 1? When rho is minus 1, let's copy and paste this one. When rho is minus 1, we have a very interesting case. When rho is minus 1, when rho is minus 1, let's blow up. When rho is minus 1, okay, then rho is minus, we have this case. When rho is minus 1, when rho is minus 1, well, we don't have enough space, so when rho is minus, rho is minus 1, then rho is minus 1, this becomes minus, so it's negative. So it means that, again, we use this one. Right? This is the sigma p square. And when rho is minus 1, it becomes simply 1 minus alpha square, sigma 1 square, minus now 2 alpha square, right? And then this is simply 1 minus alpha sigma 1 minus alpha sigma 2 square, right? So it means that now sigma p square, no square, right? Sigma p becomes simply 1 minus alpha sigma 1 minus alpha sigma 2. And then now it is possible to make it 0. It is possible to make 0 when alpha, right? When, when 1 minus alpha ratio is simply same to sigma 2 sigma 1, right? When we have this one, we can make exactly alpha equals 0, right? So it is actually we solve it, we can solve it as 1 over alpha minus 1 equal 1 plus sigma 1 over sigma 2. So therefore, when alpha is sigma 1, we can basically create riskless set. We can make risk 0. Let's take a look at this intuition of the equation. So when this is 1, when first asset is more and more risky. When sigma 1 is high, in order to make our asset risk free, we want to hold less and less of that. So when this sigma 1 is large, well, this one is actually 1. Let's make it clear. This is 1, right? This is 1. This is not good, okay? Okay, this is 1. Okay, 1. When the first asset is more and more volatile, we want to hold it less to make risk free, right? So when sigma 1 is large, alpha is large, then even when alpha is large, it means that we hold more and more asset too. Right? On the other hand, when sigma 1 is small, it means that asset 1 is less volatile. So in that case, in order to create risk-free asset, we can hold this more and more. Right? So that's the intuition of this one. Right. So when we hold portfolio in this ratio, we can make risk zero, sigma p zero. That have with this case, right? When rho is -1, we have exactly this one. So in the portfolio case, now it is possible to make risk free, so we can achieve this point. We can achieve this point, right? And then the ratio between this one is the sigma 1 over sigma 1 plus sigma 2, right? By holding this ratio, we can exactly make this risk zero. So we have a huge diversification benefit of this area. Right. So what if we have more than two assets? Now think about this. So now currently in this case we assume we have only two assets, S1 and S2. Actually S2, then we have this efficient frontier. What if we have more than two assets? Suppose we have somewhere asset over here. Then actually, if we have more than two assets, like for example 3 assets, then actually we can do very well. Suppose we have 3 assets. Now, the efficient frontier perfectly covers this one. So by combining those three, we can do much better than holding any of individual assets. We can do much better than that. So in general, we can achieve this one. So if we have more than two assets, in this case, we have, in this particular unit, we have many assets. So they are like individual assets, and then we can calculate the frontier for the efficient frontier, the best we can do. And then here, it is global minimum variance portfolio. This point is important because we are usually interested only in this part. This part is clearly efficient. However, well, compare this one and this one. Well, they have same risk. However, this point, let's compare this one and this one. These two has exactly the same risk, but this one has a higher expected return. So we prefer this one. So we don't want to hold this one. So really, the relevant efficient frontier becomes this part. Now next page is some example. Example of this one. Now let's make an argument such that suppose we have efficient frontier, something like this one, efficient frontier, and let's assume that there is two portfolio in efficient frontier. Portfolio is this one and this one. What if we form the portfolio with two assets? My argument is that if we form the portfolio with two assets, it generates risk efficient frontier. Alternative speaking, what I want to say is that we don't need them. We don't need any of these assets inside the efficient frontier. If we have any asset on the efficient frontier, with only these two assets, we can generate entire efficient frontier. So all we need is just two portfolio in the efficient frontier, because with two assets we can perfectly generate this efficient frontier. Then the question, why? Why with only these two assets we can create this? Why we don't need other thing? Why we can generate only two with the efficient frontier? Any two assets in an efficient frontier can span the efficient frontier. That's my point. Okay. Any two assets in an efficient frontier can span the efficient frontier. Okay. So a fine combination of two portfolio at an efficient frontier. So it is basically portfolio holding like 30% and 70% or 50% and 50%. And if I weigh sum to one, it is a fine combination. So it is basically portfolio combination. Then why? Question why? Why we need only two assets? Why we don't need this any asset inside the efficient? We need only two assets to cover this one. Why is that? Well, we studied this after the break.